Like we'll have for each of the trig videos, this one I'm going to split into two parts again since these can be a little bit longer problems. This one will have right triangles and trigonometric values. So for number 1, use a reference angle to find the exact values for all 6 trigonometric functions for a 240-degree angle. So we'll go through and review first of all what we mean by a reference angle by graphing our 240-degree angle first of all. So remember here, first of all, whenever you're doing this, we need to sketch out our curve of our circle. Remember, if you're rotating around here, we would have, that would be 90 degrees if we stop on the y-axis there, so we need to keep rotating around. And if we go around to the negative x-axis, we are then at 180 degrees. So we still need to go further, but we don't need to go all the way back to the y-axis. We'd be part way there. So this would be about 240 degrees. Because remember, if you go all the way over to the y-axis again, then you'd have a total of 270 degrees, since 180 plus 90 would give you 270. So we want to be somewhere between the 180 degree angle that we'd have on this negative x-axis and the 270 degree angle. So the reason why this part is important is so that way then you can try and figure out what this reference angle is. The reference angle is whatever this angle is formed from the x-axis down to our angle, and it's always whatever the closest x-axis is. So in this case, the negative x-axis is closest, and like I already said, that would be at 180 degrees. And we know that the total rotation here is 240 degrees. That means we had to go an extra 60 degrees to get to that final point there. So that would be your reference angle, would be 60 degrees. The reason we want that is because then we can use the table that we had on page 766 in the PDF file, or that you could also find on MyMathLab if you have access to that. So we have table 3, and it's page 766. And that can help you with trying to figure out how to get the exact values for these. So you'll notice there that it has the 60-degree angle as one of the values, but we have to be careful of the signs that we're going to have for these values. So you'll notice here for the x value, whenever you're dealing with a 60-degree angle, it'd be 1/2, or in this case, since we're in the third quadrant, then we'd be at a -1/2 for the x value. And then for your y value here, we would be at a negative square root of 3/2 instead of a positive. Once again, because this point down here is in the third quadrant. Remember, if you're labeling the quadrants, we start out, we have 1, 2, and then the third quadrant is down here. So the x and the y's are both negative whenever you're in this quadrant. And whenever we're dealing with these, we're dealing with a unit circle, which remember means that the length of that radius is 1. So that'll help you then to come up with what all 6 of your trig functions are here. So we already have some of those set up. So we'd have for the sine function here, we would have sine of 240 degrees would be equal to our y value here, which remember the y value in this case would be that negative square root of 3/2. And then I am going to go ahead and write right below it the reciprocal now that we've done a few of these. So remember, the reciprocal is your cosecant. So the cosecant of your 240 degrees would be a -2 over the square root of 3. It is the reciprocal. You would flip that fraction around to get the cosecant. Or the way that you'll see it in the book and in some of those problems is you'd have -2 times the square root of 3 over 3. To get that, what they're really doing is multiplying the top and the bottom of this fraction by the square root of 3. This process is what is called rationalizing the denominator, getting the denominator so we no longer have a square root down there. So that would be in terms of your cosecant function there. And then for your cosine, it's going to be like the cosine of the 60-degree angle, except, once again, it is going to be negative here, since our x's are also negative in the third quadrant, so we'd have a -1/2. And then we can do the reciprocal of that one, which is our secant of 240 degrees. Which would then give us a -2/1, which simplifies down to -2. Make sure that you are simplifying all of your answers if they can simplify. So I'm boxing the ones that are the reciprocals that we had to simplify. And then we'd have our tangent and our cotangent left. So for our tangent, once again, you can see that in the table for what it is for a 60-degree angle if you refer back to that table in the PDF file on page 766 for the trigonometry stuff. We would have a negative square root of 3 over a -1, which then simplifies down to a positive square root of 3. Or you can think of it here that we'd have a negative over a negative. Since both the x and the y are both negative, the final answer is positive, since negative over a negative is a positive. So similarly for our cotangent here, it would also be positive, but it'd be 1 over that square root of 3 that we got for the tangent function. But once again, we can rationalize the denominator by multiplying the numerator and the denominator there by that square root of 3. So then that's how they get that answer there of the square root of 3 over 3 for our cotangent function. So all of those reciprocal functions I have boxed in the answers. The sine, cosine, and tangent are similar to what you'll see in the chart there in that table 3. Some of those are just the opposite signs since we are down in quadrant 3 instead of quadrant 1 like you would have for a 60-degree angle. So make sure if you do have questions on this, make sure to ask, and we'll do number 2 in the next video.